So this is the section 6.6 notes on right triangle trig. And actually this is going to be the day that's going to seem the most familiar because this is exactly what you would have done back in geometry. Now I don't expect you to remember it. I'm going to teach it from the beginning, but this is going to look exactly the way you would have talked about it back in geometry. So think about it this way. We have been talking about reference triangles on an XY axis. So here's my XY axis, and you might say something like, hey, suppose I have a 45-degree angle. So that means this angle is 45. And we talked about how you could drop the perpendicular line so that you would have the reference triangle. And so because it was on the XY axis, we always defined the sides in terms of X, Y, and R, okay? But today we're going to say, well, what if we take the triangle off of the XY axis? If we don't have an XY axis and we just have a triangle, then it doesn't make sense to define it in terms of X, Y, and R. So that's why we're going to define it, everything in terms of wherever your reference angle is. So if this is my reference angle, and I'm going to make it be generic, I'll say this angle is theta, and I'm only choosing this one. I could choose the other angle if I want. Then instead of X, Y, and R, we're going to talk about if the sides is opposite the angle, so the side opposite the angle would be over here, or the side that's adjacent, meaning touching the angle. So this is going to be the adjacent. And notice the opposite and adjacent are the legs of the triangle. And then the hypotenuse, we're going to just call hypotenuse. Okay, and so notice when you say adjacent, that means touching. There's actually two sides touching angle theta, but one of them is the hypotenuse. And since we already are calling that hypotenuse, that means it's one of the legs of the triangle that we're calling the adjacent. So with that in mind, instead of defining the trig functions in terms of X, Y, and R, we now define them in terms of opposite, adjacent, and hypotenuse. Again, this is how you would have learned it back in geometry. So the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is opposite over adjacent. And since these are the reciprocal functions, we would just flip them over. So cosecant is the reciprocal of sine. So it's the hypotenuse over the opposite. Secant is the reciprocal of cosine. So it's the hypotenuse over the adjacent. And cotangent is the reciprocal of tangent. So it's the adjacent over the opposite. Now remember, it's all about what angle you're talking about, okay? In this case, we're saying if it's angle theta. So when I look down here, well, let me fill that in the blank, where it says, note, opposite and adjacent sides are determined by the angle, okay? So down here, for example, for this example, I'm not going to use theta because none of these angles are labeled theta. So let's look at the first one. If I say, what's the sine of angle A? It's all about the angle. So that means this is my reference angle. And so if I'm referring to angle A, and I know sine, I'll just put it over here. I know sine is opposite over hypotenuse. The opposite of angle A is 14.4. And then the hypotenuse on this triangle is 17. If I want the cosine of angle A, well, the adjacent to angle A would be 9. And the hypotenuse we said was 17. And for tangent, again, if we're referring to angle A, the tangent opposite over adjacent would be 14.4 over 9. But if we are referring to angle C, then this is my reference angle, okay? And so since sine is opposite over hypotenuse, the opposite of C would be 9. Hypotenuse is still 17. So the hypotenuse is the one thing that does not change because it's always opposite the right angle. But opposite and adjacent will change depending on which angle you're using for your reference angle. And the cosine of C, so the adjacent would be 14.4 over the hypotenuse, which is 17. And then the tangent of C, opposite over adjacent, would be 9 over 14.4. So I hope what you're seeing here is the angle is so important. You'll never write a trig function and just say what is the sine of something. So you always want to have an angle written down, because that's how you know which side is opposite and which side is adjacent. Okay. Whoops. So look down at number 7. Let's do the same thing. The sine of angle P. So if I'm referring to angle P, this is my opposite, this is my adjacent, and this is my hypotenuse. So for sine, opposite or hypotenuse is going to be 7 over 25. But then when it says cosine of R, so now we're referring to angle R. So if angle R is my reference angle, and I know cosine is adjacent over hypotenuse, and so in this case the adjacent is the 7 over 25, and so you'll notice the sine and the cosine are the same, but that's because you're referring to two different angles. Okay, and then the tangent of R would be the opposite over the adjacent, but in this case we don't know what the opposite is. Well, how would I find that third side? You'd have to do your Pythagorean theorem. So you could say, just a little FYI, we tend to label sides using lowercase. So if this is capital R, then we would call this side lowercase r. And if this is capital Q, we would call this lowercase q. And if this is angle P, then 7 down here, the opposite side would be lowercase p. And just a little FYI, you should have learned about that back in geometry, but whatever. Just so you know, whenever you see me label them, that's how I'm going to do it. So tangent is opposite over adjacent. If I do my Pythagorean theorem, it's going to be 7 squared plus r squared equals q squared. And you can use your calculator, do the math, and basically r is going to come out to be 24. So tangent of r, opposite over adjacent, is going to be 24 over 7. Okay, the tangent of p, okay, so if we're thinking about p, tangent opposite over adjacent would be 7 over 24. And then for q, so q is the right angle. So the sine of q, the opposite over the hypotenuse. Well, in this case, since q is the right angle, the opposite is the hypotenuse. And so the opposite over the hypotenuse would be like 25 over 25, which is 1, which hopefully that makes sense, because since q is the 90-degree angle, really this is saying what's the sine of 90. And if you use your chart, isn't that what we defined sine of 90 to be? Equal to 1. So it all fits together. Okay, one thing that we do with this is we learn how to solve triangles. And solving triangles simply means find all the angles and all the sides. Okay, so you're going to be given some information. So remember, the capital letters are the angles, and the lowercase letters are the sides. Okay, so I already know angle A is 90, and I don't know angle B or angle C. And I know side A is 19, because remember it's they're labeled as the opposite. So side A is 19. Side C is 12. And side B I don't know. So that's all of my given information. Okay. Well, first thing, why don't I go in and find side B? If I know 2 of the sides, in order to find the third, I could just do Pythagorean theorem. So b squared plus 12 squared equals 19 squared. And if you'll just show me your setup for your Pythagorean theorem, you can do all the math in the calculator. So in this case, for the math, let me scooch this over here. For the math, so I know I'm going to do 19 squared minus 12 squared, but then I'm going to take the square root. So I'm just going to do it all in one step. So the square root of 19 squared minus 12 squared. So that means B is going to be 14.7. We're going to round the sides and the angles to the 10th. So side B is 14.7. So make sure you put it here, because this is the sides. Okay, so this is 14.7. And so now I'm going to go in and find the angle. It doesn't matter which one you choose. Let's say I choose angle C. So I'm going to use this for my reference angle. Since I know all three sides, it doesn't matter which trig function I pick. I'm just going to randomly say the sine function. So I'm going to say the sine of angle C equals, well, from angle C, the sine is opposite over hypotenuse. So that's going to be 12 over 19. So remember how we learned to use the calculator? If we're trying to find the angle, that's where you press the second function. So I'm trying to find the angle for sine. So I'm going to say second sine. And then the answer is 12 over 19. So for the answer, I'm just going to type in 12 divided by 19. And that angle is going to be 39.2 degrees. So angle C is 39.2 degrees. Now, if I want to find angle B, I could go in and do another trig function, but let's use our geometry. Don't we know that all of the angles of a triangle have to total to be 180? So couldn't I just, add them up, subtract from 180? What I usually do on this, just because I think it's a little easier, since I already know A is 90, so basically that means that the other two angles have to total 90. So I'll just subtract that 39.2 from 90. So 90 minus 39.2, whoops, 39.2 is 50.8. So angle B is 50.8. So I always want you to show your setup. And so the minimal amount of setup was to show me which trig function you used, and then the setup that you used for your Pythagorean theorem. Okay, so let's look down here at number 13. So let's fill in everything we know. I know angle Q is 57 degrees. Angle P is the 90 degrees. Side P is 19. And I think that's all we know, right? Okay. Well, to me, in this case, it would be easier, first of all, to find your angle, right? Because I'm only missing the one angle. So if I subtract 57 from 90, let's see, what's that going to be? 33. So angle R is going to be 33 degrees. And so now I know all the angles. So I'm going to pick a trig function. I need to decide which trig function I want to pick. I'm going to use the 57 just because that's the one we were given. So I'm going to use the 57 as my reference angle. Now, I don't want to just pick any trig function because think about this. I only know one side. I know the hypotenuse. So I just want to make sure I pick a trig function that uses the one side I know. So I need to pick a trig function that uses hypotenuse. And it doesn't matter which one. So I could pick sine or cosine. So let's say, just since up the top I use sine, I'm going to use cosine this time. So I'm going to say the cosine, write down the angle you're referencing. So the cosine of 57. So if I'm referencing the 57 degree angle, then I want adjacent or hypotenuse. So the adjacent is going to be the R. So adjacent over hypotenuse we know is 19. So I can't stress enough how important it is to write down the angle, because that's how you know which side is the adjacent and which side is the opposite. Okay, so let's fill in what we know. I know that I'm trying to solve for R. So first I'll find the cosine of 57. So I want the cosine of 57. And there's my answer. But now if I want to solve for R, doesn't that mean to get rid of the 19, wouldn't you just multiply by 19? So I'm just going to take that cosine of 57 and multiply by 19, and I'm going to get 10.3. So I know R is 10.3. Okay, and now that I know R, again, I could either pick another trig function to find Q, or I could just do a Pythagorean theorem. So I think what I'm going to do is I'm going to say 10.3 squared plus Q squared equals the hypotenuse squared. So if I'm going to do that on my calculator, since I know I'm going to take the square root once I subtract, I'm just going to say square root of 19 squared minus 10.3 squared. So I know Q is let's see, that's going to round up to 16.0. So Q is 16.0. And no, you don't really have to write 0.0. I'm just going to write it so that you know I actually did round to the 10th. Okay? Now, we're still finding sides of triangles. We're still using trig functions, but we need to do a little algebra refresher. So we did this in one of the last problems. If I want to solve for x, the easy way to do that would be to multiply by 3 because the x was on the top, and so in this case we know x equals 30. But that doesn't work on number 15 because the x is in the bottom, right? And so getting rid of the 3 kept the x on top. Great. But just getting rid of the 3 isn't going to do me any good here. So maybe it's easier to think of this as like 10 over 1. Because when you have a fraction equal a fraction, can't you do like cross multiplication? Whoops, let me make that a skinnier thing there. Kind of cross multiplication. So you're going to have 10x equals 3 times 1. And then in order to solve for x, you're going to do 3 divided by 10. So that's what you're actually doing. A lot of times, since we do this so often, in my mind, I just kind of picture it. I picture to myself, well, hey, if I multiply by x, it's going to move x up over here. And if I divide by 10, it's just going to move 10 down there. So do you see I'm going to end up with the x on the left and then the 3 over 10 on the right. So however you want to picture that so that that's an easy computation. Okay. So number 16. So we're not trying to find all the sides and angles. I'm only trying to find x. So in this case, I'm only trying to find that side of the triangle that we're labeling as x. Well, here's what I'm thinking. Use what you're given. I'm given this angle, and in reference to that angle, 15 is the adjacent, and x is the opposite. So let's use opposite and adjacent, which would be tangent. So I'm going to say tangent of 23 equals the opposite, which is x, over the adjacent, which is 15. So this is a scenario where x is already on top. So I'm just going to find the tangent of 23 and then multiply that by 15. So you can either do tangent of 23, enter, and then times 15, or you can do it all in one step, as long as you close the parenthesis on that tangent of 23. So x is 6.4. So x is 6.4. Okay, so when I look at number 17, so what do I want to use? Well, in this case, I don't even need a trig function. I mean, this is a basic geometry problem. Couldn't I just do Pythagorean theorem? Isn't x just the hypotenuse? So I could say 34 squared plus 27 squared equals x squared. So this time, in order to use my calculator, I'm going to take the square root of whatever I get when I add those. So I'll just do it all in one step. The square root of 34 squared plus 27 squared, enter. And x is going to be 43.4. Now in this one, yes, I know I could have gone straight to my calculator, but remember how earlier I said I at least want to see your setup. So even though you can do all the math on the calculator, I at least want to see this because that tells me what you're doing on the calculator. Up here, I at least wanted to see this because that tells me what you're doing on the calculator. Okay? On number 18. Well, again, they gave me the 39-degree angle, and I know I could find the other angle, and that's perfectly fine if you want to, but I mean, I don't see any reason why. Why find extra? So if this is going to be my reference angle, x is the hypotenuse, and that would make 15 be the opposite. So if I want to use the one that uses opposite and hypotenuse, that's going to be sine. So I'm going to say the sine of 39 equals the opposite over the hypotenuse. So here's a situation where the x is in the denominator. So I can't just do sine of 39 and then multiply by 15. So picture it this way. If I'm going to solve, I'll multiply by x. That's going to move it up here to the left. And then I'll divide by the sine of 39. That's going to move it down to the bottom. So in my calculator, I'm just going to put in 15 over the sine of 39. So in my calculator, I'm going to put in 15 divided by the sine of 39. And that's going to give me X is going to be 23.8. So again, it's fine that you show the middle step, but the steps that I really cared about were the initial trig function setup and then the answer. This step right here was just me kind of showing you my thinking to help me solve. All right, so that is section 6.6 in the notes.